Assalamualaikum. Today we would like to present about experimentary, which is measuring gravitational acceleration. But first, let's meet our group members. First, myself, which is Nur Hafiza binti Gaini.
My name is Nur Natasha Darusha binti Abdul Halim.
My name is Amira Natasha binti Ruslan.
Hi, my name is Amira Adani.
Hi, my name is Nathira binti Asma Peter.
My name is Nur Maisara binti Jamaluddin.
Now, let's move on to first one, which is objective. First, to investigate the functional relationship between height of fall and falling time. Second, to determine the acceleration due to gravity, G, by studying the motion of freely falling body.
In a simple terms, gravity is the force by which a planet or other body draws an object towards its center. The concept of acceleration gravity is the acceleration by an object due to gravitational force. Gravitational acceleration is a vector quantity, meaning it has both magnitude and direction. An object that falls or moves only because of the action of gravity is said to be free falling, and its motion is described by Newton's second law. A linear motion is present if the mass of the object is accelerated from rest in a constant gravitational force, which is mg. The result were obtained by applying the coordinate system so that the x-axis represents the direction of motion and solving the associated one-dimensional equation motion. Due to gravitational acceleration that is a constant, the height of a fall is proportional to the time spent falling.
Hi, so this is the apparatus for this experiment. Firstly, we got release unit here. See? Okay. And then we got impact switch, digital counter, support base, right angle clamp, plate holder, meter scale, and support rod, connecting cord, and ball bearing.
Firstly, measure the height of the fall. Make sure to raise the pen after each single measurement. Next, release the ball bearing. Lastly, record the reading of the fall. Repeat the procedure for the next reading.
This is the result obtained.
Analysis. First, from the data, what graph for? A. Height of falling as a function of falling time. B. Height of a fall as a function of the square of falling time.
Analysis. First of all, we got the height of fall as a function of falling time graph, and next we have the height of fall as a function of the square of falling time graph. For the second question, using the gradient formula, the gradient of the graph is 4.99 ms negative 2, while the value of m is 9.98 ms negative 2. For the third question, the uncertainties is plus minus 0.17 ms negative 2. And for the fourth question, the percentage error is 1.73%. And lastly, the fifth question, is there any experimental error? Discuss. Yes, there is a theoretical error from this experiment in which the value of G resulted from this experiment is different from the actual value of G. The measured value of G is 9.98 ms negative 2, while the actual value of G is 9.81 ms negative 2. This might have happened due to the inaccurate reading during the observation. This error can be avoided by taking several readings.
Conclusion. The main objective for this experiment is to investigate the functional relationship between height of fall and falling time and determine the acceleration due to gravity, g, by studying the motion of a freely falling body. Based on the result that has been obtained, it's a proof that the higher height of fall, then the falling time getting longer. As example, ball bearing fall from 0.05 meter and average time of falling time taken was 0.0929 seconds. Then, this increasingly until at height of fall at 0.50 m and average of falling time is 0.3144 seconds. This experiment also has a proof that acceleration due to gravity is 9.81 meter per second. So, the hypothesis is accepted and the main objective also achieved. Next, to reduce any error in experiment, when measure the height, make sure place the eye such as the line of view is perpendicular to the scale read.
As we know, the gravitational acceleration is object's free fall acceleration with a uniform rate even its masses due to gravity force. Next, gravitational acceleration is a factor quantity because it has both magnitude and direction. The time taken reading were repeated 3 times to get accurate reading. The sum of the two closest readings was divided into 2 to get average reading. Based on the result, the head of fall, which is h, increased proportionally with the time taken, which is s. This shows that the relationship between the distance and time of a falling object is always proportional due to the constant gravitational acceleration on Earth, which is 9.81 meter per second. The graph shows that the rate of fall is proportional to the square of the time spent falling. When the rate of fall and time spent falling will increase, cause the graph to be linear. Hence, it proves the rate of a fall will always be proportional to the time taken. Lastly, this experiment has experimental error that affect result, for example parallax error, that cause because not exactly perpendicular to the ruler.